Hello friends, welcome to my channel Electrical Master. This video we are going to discuss about how to read earthing layout in the substation. If you are visiting my channel first time, please subscribe to my YouTube channel and click the bell icon. Then you will never miss our updated videos. Let's go to the video. So we need to know how to read this earthing layout. Before reading this earthing layout, maybe you will see this drawing, you will get the confusion. What are the things inside in this earthing layout? Before we are seeing this drawing, we will just understand the basics. What are the things inside this drawing? So first one is earth pit. We know earth pit, it is like a house of the earthing connections. See, the inside of the earth pit there will be earth electrode and earth conductor will be there. Earth electrode is nothing but a earth rod. You can see this picture. This is the earth rod. Also it is called a earth electrode. And earth conductor. Earth conductor is the earthing cable. So this both earth rod and earth conductor is connected in the inside of the earth pit. You can see here this picture. This is the earth pit. So inside we are connecting the earth rod. We are digging this earth rod minimum 3.5 meter inside the ground. From the top side of the earth rod we are connecting the earth cable to the earth bus bar. The second significance is a grid earthing. Grid earthing is simple. We know that I told the individual earth pit connection. Same way you are connecting the n number of earth pit interconnected together through the earthing cable in the underground. This is called a grid earthing. See here E1, E2, E3, E4. These are the earth pit. So we are connecting the each earth pit between minimum distance we are keeping 3.5 meter through underground bare copper conductor cable. Likewise, if you are connecting the n number of the earth pit, it is called grid earthing. The purpose of grid earthing is it is providing the common ground for our connecting equipment. In case any one of the earth pit is failure, so the remaining earth pit will actively participate to distribute that fault current to the ground. That is the purpose we are using this grid earthing. And third, earth bus bar. Earth bus bar we can say it is the hub of the earthing connection. Normally we know that earth pit, from the earth pit we are giving the input cable to this earth bus bar. This earth bus bar only act as a DB distribution board, like a earthing distribution board. From this earth bus bar only we are taking the output to the individual equipment. See here, these are the individual cable and two big size of the earthing connection. It is the incomer of the earth bus bar. So as per the standard, you have to provide minimum two incomer, two earth pit connection input to this earth bus bar. And the output, it's based on the number of holes present in the bus bar. You can take as much of possible. And fourth, it is a conductor size. It is the important in the earthing layout, because you should know what are the cable size used for which purpose. The first one is earth grid. I already told earth grid means it is the interconnection between the earth pit. So minimum cable size you have to use 300 square mm, and also it should be bare copper conductor. It's not a sleeve type. So you have to use the bare copper conductor, and also you have to connect it in underground installation. And second, earth pit to neutral of the transformer. Actually we know it's a separate, earthing is separate, grounding is separate. Grounding means the neutral of the transformer or generator connected to the earth pit. It is called grounding. My last video I already explained about what is difference between that grounding and earthing. If you do not watch that video, I'll give the link in the description box. You can get it. Also you can click this eye icon, you will get that link. So for this earth pit to neutral transformer, you have to use 120 square mm of the copper cable. This is also you have to use the bare copper conductor. And third is the earth pit to earth bus bar. This I already told, this is earth pit to earth bus bar. This is the incomer of the earth bus bar supply. You have to use minimum cable size required 75 square mm, and here you can use that PVC yellow green coated that PVC cable, it is acceptable. And fourth is a earth bus bar to the equipment. So from the distribution of the earthing bus bar to the individual equipment, you can use minimum size 35 square mm as based on the equipment. Sometimes if you are connecting for the dBs, you can connect 10 square mm also enough. For 35 square mm minimum needed for the like a transformer, generator, like a heavy load switch gears, you have to use 35 square mm. For a less load like dBs, like emergency dBs, all those loads, you can use 10 square mm also enough. So now you understand all the significance of the earthing. Now we will see how to read this earthing layout. See this earthing layout. Actually, this is outside boundary of this drawing. This is called substation. So these are the walls of the substation, and these are the entrance door of the substation. And see here inside, this is the 11 kV switchgear board. 11 kV switchgear board, it's connected this side, and this is the RCP panel, remote control panel for this 11 kV switchgear. And this side you can see this is the 440 volt switch board, and this battery charger and lighting DBC here, and this is the battery room to support this battery charger and control supply for the switchgear. And you have to see here, this is the controlling room, and here this side HVAC room for the AC distribution to this substations. And here you can see corridor, and this is some of the offices there, and restroom is there. And if these are the inside of the substation. If you are seeing the outside, this is two transformer is placed, transformer 1 and transformer 2. It is giving that supply to the substations. Okay, now you will understand overall of the drawings. Now we will see how the earthing is connected in this substation. See here, the outside of that substation, everywhere they put EP1, EP2, EP3. Likewise, all the substation surrounding is connected with the EP numbers, and finally it is end up with the EP25. It means earth pit. EP means earth pit. So total 25 numbers of earth pit they connected, and all the earth pit is interconnected with one by one, and starting from EP1 and end up with EP25, and finally it is returned back to the EP1. So this is called grid earthing. So this is earth pit. Individual earth pit is connected between n numbers. This is called grid earthing. I already told in that previous starting of this video. So this cable they are using 300 square mm earth pit to earth pit connection. And see here, inside of the substation, they mounted the earth bus bar, like the number is EB1, earth bus bar 1, bus bar 2, earth bus bar 3, bus bar 4, 5, 6, 7 and 8 and 9. Okay, 9 and 10, 8, 9 and 10. So total 10 numbers for earth bus bar they are used. So as per that standard, each earth bus bar you have to provide 2 incomer of the earth pit connection. See here EB1, it is taking from EB earth pit 1 2 and earth pit 2. Both incomer is connected in the EB1, and distribution it's like that, in numbers you can take it here. Similarly EB2, earth pit 4 and earth pit 5 is connected. From that it is going to the cable tray of the switch gears and body of the switch gear, all the place. Similar way you can take any earth bus bar. Any earth bus bar taking, it will be connected with 2 incomer, and it will going to number of outgoing cables. And next significance we see that I told the neutral of the transformer you have to connect separately. See here the earth pit number 15. From the earth pit number of 15, one connection it is going to the earth pit earth bus bar number 10. So from that earth bus bar 10, they are taking body of the transformer is earthing is connected, and neutral transformer grounding is separately taken. It is connected to the earth transformer, separately connected to the earth pit 15. See here the transformer number 2, that is also same way EP16. One end is directly connected to the earth bus bar 9. From the 9 they are connecting that body of the transformer earthing, and neutral of the transformer separately they are taken and connected with the earth pit EP16. So neutral wire they used 120 square mm copper bare conductor copper cable they are using, and from earth pit to the earth bus bar they are using 70 square mm. Okay, so from the earth bus bar to individual component like all this body of the switch gear and battery charger, like heavy equipment like transformer body, those equipment they are using 35 square mm PVC coated yellow green cable normally they are used. For the lighting dBs you can see here, this bus bar to the lighting dB they are using maybe 10 square mm PVC coated yellow green cables they are used. So now you will understand how to read this earthing layout and what are the significance in the earthing layout, like earth pit, grid earthing, what is mean by grid earthing, minimum distance between the grid earthing it's 3.5 meter, and how earth bus bar and earth bus bar input supply, minimum 2 input supply unit to give, and same way the cable size from the earth pit to the earth bus bar, all the things you know I hope. If you have any doubt you can write in the comment box. In my next video I will show how to design this earth pit, number of earth pit requirement for our substation or our any office premises, any buildings, how we can design, how many earth pits are required, and also how to calculate the earth resistance value. So those things we will discuss in my next video. I hope you will like this video. Please give a thumbs up and don't forget to subscribe my YouTube channel. Thank you.